Hello and welcome to our class, Computer Programming 2. Now we are on the first and second week of your prefinals, and we are discussing enumerations and nested classes. So if you're interested with these kind of video tutorials, don't forget to like, share and subscribe. Also click the notification bell so you won't miss out our YouTube videos. An enumeration, enum, is a data type that contains a fixed set of constants. Enums are good to use when you already know all possibilities of the values or instances of the class. They can be declared on their own or within another class. With numeric or string constants, you can pass an invalid value and not find out until runtime. With enums, it is impossible to create an invalid enum value without introducing a compiler error. Enumerations show up whenever you have a set of items whose types are known at compile time. Common examples include the following: compass directions, months of the year, cards in a deck. To create an enum, declare a type with the enum keyword, an identifier for the type, and a list of values called enum constants. The enum constants are the only allowed values for the type. See the example below. After creating an enumerated data type, you can declare variables of that type just like the following: period p. You can assign any of the enum constants to the variable, such as the following statement: p equals period dot midterm. An enumeration type such as period is a class. Its enum constants act like objects instantiated from the class, including having access to the methods of the class. These built-in methods are non-static. ToString method returns the name of the calling constant object. Ordinal method returns an integer that represents the constant's position in the list of constants. The first position is 0. Equals method returns true if its argument is equal to the calling object's value, compared to method returns a negative integer if the calling object's ordinal value is less than that of the argument, 0 if they are the same, and a positive integer if the calling object's ordinal value is greater than that of the argument. You also can use comparison operators with enumeration constants instead of using the compare to method to return a number. Several static methods can also be used with enumerations. These are used with the type and not with the individual constants. Below are two useful static methods to use with enumerations. Value of method accepts a string parameter and returns an enumeration constant. Values method returns an array of the enumerated constants. You can declare an enumerated type in its own file, where the file name matches the type name and has a .java extension. You can also declare an enumerated type within a class but not within a method. In the following example, a period enumeration is declared, while a period variable is declared in the main method. Then, an enhance for loop declares a local period variable named p that takes on the value of each element in the period.values array in turn so it can be displayed. The user is prompted to select a period, which is converted to its uppercase equivalent. The value of method is used to convert the user's input to an enumeration value. The program also retrieves the position of the selected period in the enumeration list. Below is a sample output of the above code. You can also use enumerations to control a switch structure. The following example contains a class that declares an enumeration for pizza sizes and then uses a switch structure to display the prices. Below is an example of code. The code is a Java program that demonstrates the use of an enumeration enum called size. It defines three constants of the enum type, regular, large, and party, and assigns one of them to a variable s. It then uses a switch statement to print the price of a pizza based on the value of the s variable. If s is regular, it prints 381.00, if it is large, it prints 602.00, and if it is party, it prints 799.00. In the above program, s is assigned the large constant, so the output is, price of pizza is 602.00. Using enums makes the values type safe. Type safe is used to describe a data type, for that allows only appropriate behaviors. As with other classes, you can also add methods and other fields to an enum type. Nested class. In Java, you can create a class within another class and store them together. Such classes are called nested classes. The containing class is the top-level class. There are four types of nested classes: static member class, has access to all static methods of the top-level class. Non-static member class, inner class, requires an instance. It has access to all data and methods of the top-level class. Local class, defined within a method body. Anonymous class, a special case of a local class that has not identifier. The most common reason for nesting a class inside another is because the inner class is used only by the top-level class. Being able to package the classes together makes their connection easier to understand and their code easier to maintain. The sample class below describes houses that are being sold by a real estate company. The class might contain separate fields for the listing number, price, address, and area. Although the listing number and price go with the real estate listing, you might also decide that the address and area really go with the house. You might create an inner class like the one in the sample program below. The program is a Java class called Real Estate Listing that represents a real estate listing. It has private instance variables for the listing number, price, and house data. The house data is stored in a private inner class called house data, which has instance variables for the street address and square footage. The class has a constructor that takes in the listing number, price, street address, and square footage as parameters and initializes the instance variables. It also has a public method called display that prints out the listing number, price, street address, and square footage of the real estate listing. Overall, this program models a real estate listing and provides a way to create and display such listings in a structured way using Java. In the sample program, the inner house data class is a private class. You don't have to make an inner class private, but doing so keeps its members hidden from outside classes. If you wanted a class's members to be accessible, you would not make it an inner class. An inner class can access its top-level classes fields and methods, even if they are private, and an outer class can access its inner class's members. You usually will not want to create inner classes. For example, if you made the house data class a regular class, as opposed to an inner class, and stored it in its own file, you could use it with composition in other classes. As it stands, it is usable only in the class in which it now resides. You probably will not create nested classes frequently, but you will see them implemented in some built-in Java classes. Thanks for watching, and I will see you for the next one. Get ready for the next topic next week.